Hey everyone, welcome back to episode 2 of the Godot version 3.4, your first game tutorial. My name is Robert. If you're with us last episode, we left off writing the clamping functions or the calls to the clamping function for our game. Let's go ahead and fire up Godot here and take a look where we left off. Go ahead and start your Godot game engine. I have my material here in the YouTube audio or YouTube tutorial. Let's go ahead and open that up. All right, and you'll notice here that we have our player sprite with the animated sprite attached to it and the collision box around it. We can take a look here by selecting player and clicking our script button. We'll scroll down here to the bottom, and here we are setting our clamping player position inside the bounds of the screen. Let's go ahead and bring up the tutorial here and see where we left. Yep. Okay, and if you need the link to this tutorial, it's down in the description box below. Just click it and it'll open it up for you and scroll down. You can click choosing or Control F, find choosing animations. That's where we left off. So now that the player can move, we need to change which animation the animated sprite is playing based on its direction. So let's take a look back at Godot here, and let's go ahead and give it a play and see what that looks like. All right, so here's our game. There's our animated sprite, and you can see we can go up, down, left, right. We're clamped inside the borders of our screen. So let's go ahead and stop that. And we'll pin this over here. Okay, so here we are. So now that the player can move, we need to change the animated sprite. Change which animation the animated sprite is playing based on its direction. We have the walk animation, which shows the player walking to the right. This animation should be flipped horizontally using the flip H property for left movement. We also have the up animation, which should be flipped vertically, flip V, for downward movement. Let's place this code at the end of the process function. Actually, let's pull this off screen here so I can get a better look at it. Like I said, guys, I don't really recommend copying and pasting this code directly into it. You're better off typing it. Kind of help get you a better idea of what you're typing and how everything's laid out. You can copy and paste stuff all day. I just don't feel like you learn anything. So the tutorial is telling us we need to place the sprite animations inside our process function. So that's right here. So let's go ahead and come down to the bottom, and we'll start off by making a comment. Play, let's see, we'll just say pick correct sprite animation based on velocity. And first line here, if velocity dot x does not equal 0, colon, and remember our $ accesses the nodes within our scene. So we'll say $ animated sprite. We'll just tab that out. Dot animation equals, and you'll notice here we'll say equals, and we'll put it in a string walk. And walk is what we named it in our animated sprite. So if we click that node here, you can actually see our animations listed right here. We have up and walk, and we're able to access that just by typing the value of the name we gave to it. So we'll go back to our script. And let's see, next line, animated sprite dot animation and dot flip. Nope, not animation, dot flip V, so that's flip vertical. We'll say equals false. And let's say $animated sprite dot flip horizontal, and we'll say that's velocity or flip horizontal equals velocity dot x less than 0. We'll continue with our else, or elif, excuse me. Velocity dot y not equal to 0. Animated sprite dot animation equals up. And last line, animated sprite dot flip vertical equals velocity dot y, or y-axis, greater than 0. All right, so let's just step over this code real quick. So if the velocity for x, our x-axis going left to right, does not equal 0, we want to do the walk animation, and we'll say flip vertical is false. Animated sprite flip horizontal, right? Yep, animated sprite flip horizontal equals velocity dot x, so our xy axis less than 0. We will flip horizontal. And then we have else if our velocity y up and down, animated sprite dot animation equals up, animated sprite flip vertical equals velocity y greater than 0. So let's just go ahead and save that. We'll hit Control S and we'll click play, and we should get our proper animations now. There we go. So we can see our left, right, left, right. Our character actually turns and walks the correct direction. If we click down, our character will swim down, and we click up, we have that flip. So you can see how that works. The logic can get a little tricky in that, but just kind of read over it slowly and play with it. It should make sense to you. All right, so let's go ahead and close our debug and scroll down. Let's give us some more space. All right. And right here, it talks about the Boolean assignments. You can read over that if you like. We'll continue on. Let's see, when you're sure the movement is working correctly, add this line underscore ready so the player will be hidden when the game starts. Okay. Preparing for collisions. We want the player to detect when it is hit by an enemy, but we haven't made any enemies yet. That's okay because we're going to be using Godot's signal functionality to make it work. Add the following at the top of the script after extends to D area. So let's add our signal. And we'll say hit. So we're defining that signal. And actually, it's like a variable. Let's move it down there. So this defines the custom signal called hit that will have our player emit send out. So emit when it collides with an enemy. So actually, let's do this. Let's say signals. Export vars. And vars. Let's see, so we want to come over here and click our node. So we'll select player. Outside of the script, you don't want to click node then. You want to come over to the left side on your scene here and select your player. And you'll notice you have your inspector that has all the properties for the player, and then you have the signals that are associated with that node. And if you notice right here, you see player.gd, that's our script we created. We have our hit signal that we defined. It mentions that to you right here. Let's see, hit signal is there as well, since our enemies are going to be a rigid body 2D we want the body entered node signal. This signal will be emitted when a body contacts the player. Click connect. So let's find our body, what did it say, body entered? Body entered body node. We can double click that and it'll ask us where we want to connect it. And you can see actually the only thing we can select is the node 2D right here. So we'll say connect. And it created the function for us, function on player body entered, and we're passing body to it. All right, so on player body entered, first thing we want to do is hide it. So on hit, we're going to hide our player body. And then we'll emit underscore signal. And we get to pick it, and we'll pick hit, which is what we defined earlier. And we'll say we'll go access our collision shape. So $collision shape 2D dot set underscore deferred. And in quotes, we'll put disabled. Disabled, comma, Boolean true. Okay, so each time an enemy hits the player, the signal is going to be emitted. We need to disable the player's collision so that we don't trigger the hit signal more than one time. Disabling the area's collision shape can cause an error if it happens in the middle of the engine's collision processing. Using set underscore deferred function tells Godot to wait to disable the shape until it's safe to do so. So right here we'll have the last piece to add is a function we can call to reset. Let's see, reset the player when starting a new game. So let's add that in. Okay, function start. We'll pass the value of position. Let's add our colon here. Position equals POS. Show function. And say collision shape 2D dot disabled equals false. Okay. So let's flip back over here. So we define the on body entered function. We added our hit signal. We added hide to our ready line. Okay. So the next thing we're going to do is the enemy scene. We'll read over this. Now it's time to make the enemies our player will have to dodge. Their behavior will not be very complex. Mobs will spawn randomly at the edge of the screen, choose a random direction, and move in a straight line. We will create a mob scene, which we can then instance to create any number of independent mobs in the game. All right, and you can go on here. It gives you a link to read more about instancing. We're just going to follow through the tutorial. We won't go too deep into that. I suggest reading further into it. So click scene, new scene, and add the following nodes. So let me pin this back over to my other screen here. Click scene, new scene. And we'll pin the following nodes. So we're going to start for rigid body 2D. Let's just go to other node, rigid body 2D. And then below that, we're going to have an animated sprite, a collision shape 2D, and a visibility notifier 2D. So we'll highlight rigid body, click plus, let's say animated sprite. Go back to rigid body, don't add it as a member of animated sprite. And now we want to go collision shape 2D. Cannot type today. Create. Make sure you click rigid body again, and let's add the visibility notifier 2D. Visibility notifier 2D. And we just double clicked it there. Let's see, don't forget this child so they can be selected. So we don't want to when we modify this, we don't want to accidentally pull things into different directions. You see right here, I have the visibility notifier, then I have my animated sprite shape, and over here is my rigid body. They're all connected like that. We don't want that to happen. So let's Control Z to back all that up. And we'll select rigid body, and we'll find this right here, right next to the padlock. It says make sure objects children are not selectable. We'll click that, and now everything's locked on top of each other. So let's return it back to its default position at the origin. And let's see, in the rigid body property, set the gravity scale to 0. So let's make sure our rigid body is selected, and we'll come over here to the inspector. And we're looking for gravity setting to 0. Let's find that gravity scale. Yep. So we'll set that to 0. Yep. And so the mob will not fall downward. In addition, under the physics body 2D section, click the mask property, uncheck the first checkbox. This will ensure mobs do not collide with each other. So collision shape. No, wrong spot. Collision object 2D. Here we go. So we're going to take this layer off here. Not the layer, the mask. Uncheck the mask. Okay. So in this collision object 2D, you have layer and mask. We'll go into that a little bit more detail later on. Okay, so now that we uncheck the mask, we're going to say set up the animated sprite like you did for the player. This time we have 3 animations: fly, swim, and walk. So for rigid body, let's come over here to animated sprite. And in the inspector portion, we see frames. We'll click the drop down, new sprite frames. And we'll double click that. And we'll start adding some additional animations. So we have 3 total. So for this top one here, we will say fly. And then we have swim. And then the last one is walk. Swim. There we go. Fly, swim, walk. Let's go ahead and do our fly first. And we've selected it. And we'll click our add textures from file here. And see in our Dodge assets folder, we'll go to art. And then we have fly, all our images right here. So let's see, we're on fly. So we'll do flying alt 1, alt 2. And there looks like there's just 2 images for flying. So let's open those. And we'll select swim and do it for the rest of them. All right, so now that we added our 3 images here, we'll continue on. And it says, let's see, adjust the speed or frames per second to 3 for all animations. So let's come up here to fly. We'll just start from the top, work our way down. We'll say 3 FPS. 3. And 3. Not 53. And it says set the playing property in the inspector to on. So let's come over here. The inspector, we made sure animated sprite selected and playing. We'll put this checkbox turned on. And we see now that our animation's actually playing here. Zoom out some. All right, so let's see. We will select one of these animations randomly so the mob will have some variety. Like the player images, these mob images need to be scaled down. Set the animated sprite scale property to 0.75, 0.75. So node 2D transform, canvas item. Let's see here. Where's our scale? Animated sprite scale. Let's just find it. Scale. There we go. This is really useful if you're looking through your properties right here and cannot seem to find what you're looking for. You have this little search box right here. So that's what I did. Scale. Let's say we wanted 0.75 and 0.75. All right, and that scaled down our mob. As in the player scene, add a capsule shape 2D for the collision. So, okay, so let's say our collision 2D. Let's get rid of this filter here. Shape. I'm going to say new capsule shape. And let's zoom in so we can see what we're doing. I'll open this up a little bit. And we're going to need to rotate this. So let's say rotational 90. There we go. We'll expand this out so it encapsulates our entire player. And I think I want to start with this one here. There we go. So now our mob is encapsulated with our collision shape. And let's go ahead and save the scene. And what does it want us to name this? We'll just say mob default type there, which is TC or TSCN. Okay. Then we want to add a script to our mob. So we'll select rigid body, our scene here, and we'll click our add script button. Mob.gd is fine. Create, and it gives us our default script with some filler text here. We'll see it says extends rigid body. We want to add 2 exported variables. So exported bars. We're going to add minimum speed, min speed equals 150. And max speed should be 250. Let's get rid of some of this extra text. Let's see, when we spawn a mob, we will pick a random value between min speed and max speed for how fast each mob will move. It'd be boring if they're all moving at the same speed. Yes, it would. So let's see. Taking a look at our ready function, we will randomly choose one of the 3 animation types. So we have our ready function here. Let's get rid of pass. I'll say var mob types. We'll just create a new variable here and making an assignment to the animated sprite node. So $animated sprite dot frames dot get underscore animation names. Then we'll say animated sprite dot animation equals mob types. Let's see, we'll say, so this mob types is going to be an array because we have 3 different movement animations, if you remember, that we made. So let's flip over here to animated sprite. We have fly, swim, walk. And when we look at our script, let's see. There we go. When we look at our script, we're creating this var variable, mod types, which is an array type because we're getting the animation names of the animated sprite node. And then we're saying animated sprite.animation, and it looks like we're doing a random function, which they have as randy. I want to make an Austin Powers joke so bad, but I'll spare you. Randy percent mob types dot size. There we go. So it says first we get a list of the animation names for the animated sprites frames property. That's that var mob types. This returns an array containing all three animation names, walk, swim, and fly. We then need to pick a random number between 0 and 2 to select one of these names from the array list, starting at 0. And so that's what the Randy... okay, yeah. So it's a random function here, and we're going to say, what's that? Modulus? Mob types, size. So it selects a random integer between 0 and n1. And mob type size, that's how many things are in our array, are 3. So you must use randomize if you want a sequence of random numbers to be different every time you run the scene. We're going to use randomize in our main scene, so we won't need it here. The last piece is to make the mobs delete themselves when they leave the scene. Connect the screen exited signal of the visibility notifier 2D node and add this code. So we have our visibility notifier 2D. We'll say node, screen exited is what we want. And we'll say connect. And we'll define our function here. Say Q3. There we go. And it says this now completes the mob scene. Awesome. So let's save that. Okay, guys, so now that we have our mob scene defined, we're going to go ahead and make our main scene here. So looking at our tutorial main scene, now it's time to bring it all together. Create a new scene, add a node named main. Ensure you create a node, not a node 2D. So we click scene, new scene, and we have, let's do other node, and we're going to search node. And that's our node 2D, so we don't want to select that. We want to come all the way up to the top here, and you'll see node, and that's the base class for all scene objects. We'll click create. Looking back over the tutorial, let's see, you can create a node, click the instance button, and select your saved player scene. So we're going to select here, you see our instance child scene, and we'll add player. It says now add the following nodes as children of main and name them as the values shown. Values are in seconds. So let's see, we'll select our player. Nope, as of main, so we'll say we need some timers. Timer. And this is going to be named mob timer. Let's see, we're doing one word here. And we'll want to add the score, start, and start position. So let's just go ahead and add another one. Score timer. Maybe start timer. Then one more. This will be start position. Okay, so we've added 4 timer objects here. And we're going to set the wait time property of each of the timer nodes as follows. Mob timer will be 0.5, so let's select mob timer. Select our inspector and say 0.5. Score timer will be 1. That's the default. Then start timer will be 2. It says, in addition, set the one-shot property of start timer to on, and set the position of start timer to node 240 by 450. So start timer, one shot on, and set the position of the start timer to node 240. Okay. Let's see, position. Oh, we messed that up. So I added 4 timers here. We actually want 3 timers. And then we want to do a position 2D object. So let's get rid of this start position. Delete. We'll say add. And that was a position 2D. There we go. That makes more sense. So our position 2D object, we're going to say transform position is 240 by 450. Okay. And then spawning mobs. The main node will be spawning new mobs. We want them to appear at random locations on the edge of the screen. Add a path 2D node named mob path as a child of main. When you select path 2D, you will see some new buttons at the top of the editor. So let's select here, and we are supposed to rename this node to main. Let's do that. And we'll add our path 2D. And we're going to rename that to mob path. It's a child of main. All right, we select that, and here's these extra settings that we have now. Select the middle one, add points. So let's hover over these and find add points. We have select points, select control path points, and that plus button, add point. What do we have? Delete point, close curve. Let's do the add point. Draw the path by clicking the add points at the corners shown. So let's zoom out a little bit here. So we add our points right at the origin. 1, 2, 3, 4. After placing 0.4 in the image, click close curve button and your curve will be complete. Let's do right here. This should be close curve. So now we set our mob path. It says now the path is defined. Add a path follow 2D node as a child of mob path and name it mob spawn location. So let's select mob path, we'll add, say follow path follow 2D, create, and we're going to name that mob spawn location. So this node will automatically rotate and follow the path as it moves, so we can use it to select a random position and direction along the path. And it says our scene should look like this. So let's zoom out and we'll take a look at it, make sure it looks right. So we have our main, our player, mob timer, score timer, start position, We'll rename that mob path and then mob spawn location. So let's rename this start position. And so we'll add next a script to main. At the top of the script, we'll use export pack scene. Let's move this. We'll select our main, add, create. You'll see this extends nodes. Let's get rid of these comments. I'll say exported bars. Export. That quotes packed scene var mob regular vars var score, and let's get rid of this. There we go. And we have our ready function, and we want to call randomize. All right, so it says click the main node, and you will see the mob property in the inspector under script variables. You can assign this property's value in 2 ways. So click the main node. And we'll see the mob property in the inspector. Here we go, mob property. We exported that to the pack scene, so that's what it is there. You can assign this property value 2 ways. Drag mob tscn from the file system panel and drop it in the mob property. Or we can click the down arrow next to the empty and choose load select mob scene. So it's saying that we can find mob.tscn here, and we can just drag it, and you can see it's it says no, 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 and okay. We'll just do that. Now select the player node in the scene dock and access the node dock on the sidebar. Make sure to have the signal tab selected in the node dock. Let's read that again. Next, select a player node. So let's find our player node. Here it is. And in the scene dock, access the node dock on the sidebar. Make sure to have the signals tab selected. There we go, signals tab, not groups. And you should see a list of signals for the player node. Find and double click the hit signal that we created earlier. Should be the first in the list, which it is. This will open a signal collection dialog. We want to make a new function named game over, which will handle what needs to happen when the game ends. Type game underscore over in the receiver method box at the bottom of the signal connection. So right here, we'll say game underscore over. We'll click connect. And here we'll go add some logic. We'll say score timer. Yep. Score timer. Maybe. There we go. Dot stop. And mob timer. Stop. And then we're also going to create another function called new game. Okay, score equals 0. So player dot start pass $start position dot position and start timer dot start. All right, so we've added these two additional functions and we've connected the signal to this game over. And this is now connect the timeout signal of each of the timer nodes, start timer, score timer, and mob timer to the main script. Start timer will start the other two timers. Score timer will increment the score by 1. Let's go ahead and define these additional functions. So func underscore on start timer for time out. Timer dot start, and then score timer dot start func on timeout colon score use increment plus equals 1. Let's go and save this. We'd saved in a while. Okay, so next thing we need to do is connect the timeout signal of each of the timer nodes, start, score, and mob, to the main script start timer. We'll start the other two timers. Score timer will increment score by 1. So let's see, we need mob timer and node timeout, and we're going to connect that to the main. So we have on mob timer timeout connect, and let's go ahead and do score timer timeout, connecting it to main, and then start score and mob, and we'll connect this one as well. Nope, we have score, mob, start. That's the one we're missing. Okay, let's connect that signal. And so the first two we're going to edit, and I'm going to fix these so they kind of fall in line with the tutorial here. Let's do start timer and score timer. So let's put start timer on top, and score timer, and then mob. So for our start timer, now that's connected, let's say $mob timer dot start, and score timer dot start, and then and on score timer we're going to increment the variable score by 1 using our increment operator here. Let's see, on mob timer timeout, this function here, we will create a mob instance, pick a random starting location along the path 2D, and set the mob in motion. The path follow 2D node will automatically rotate as it follows the path, so you will use that to select the mob's direction as well as its position. Note that a new instance must be added to the scene using add child. So we got a lot to type here. I'm going to speed up the video just a little bit as I type this out. Okay, so we have our on mob timer timeout. We added our logic here. Let's take a look. So we're choosing a random location on the path 2D. So we're saying mob path divided by mob spawn location dot offset, and we're passing the randy function. We're setting it equal to. Create a new mob instance and add it to the scene. So we're creating our mob instance, adding it to the scene, and set the mob's direction perpendicular to the path direction. Set the mob's position to a random location, adding some randomness to the direction that the mob is traveling, and set the velocity, which is our speed and direction of the mob. There's a little important note down here. It says ypi. In functions requiring angles, GD script uses radians, not degrees. If you're more comfortable working with degrees, you need to use the deg to rad and rad to deg functions to convert between the two. Testing the scene. Let's test the scene to make sure everything is working. So we'll add this bit of code to our ready function. We'll say randomize and new game. So let's move this. Let's go ahead and save what we have. So we have our ready function here. So we are adding randomize, and we're going to call new game function just right here. Save again. Okay, so the last little bit we're going to finish up here is testing everything we've programmed thus far. It's going to have us set our main scene, our main node, as the main scene that runs automatically when the game launches. Press play button and select main.tscn. I know mine is not going to do that, but what you can do here is in your file system browser, you find, in this case, mob.tscn or mob.tscn, and we're going to set as main scene after we right click it. And so that's not that we do mob, no, we want to do main.tscn. We'll set that as our main scene, okay, and then we'll hit our play button and we'll see what happens. All right, you can see we got our player character here. We can go up, down, and we're going to try to dodge the creeps, and our player was hit, and you see it immediately disappeared. The mob went off the panel here, or off the screen, and eventually disappeared. All right, so that's it for this tutorial. If you found this helpful at all, please hit that like button, subscribe if you want to see more videos, ring the bell if you want notifications, and we will see you for episode 3 where we will wrap this up. Goodbye.